Well, hello everyone, and welcome to yet another problem from GeeksforGeeks. So, the problem is pretty simple. It says find the sum of last n nodes of the linked list. And as the name suggests, we are provided with a linked list. We are given a number, let's suppose in this example 3, and we need to find the sum of last 3 nodes. So, within this example, 3 plus 4 plus 10 gives us 17, and that is what our answer is. So, yeah, how do we do this? It's a quite straightforward problem, no such brainstorming. So, the easy solution which comes to our mind is we can do one thing, we can reverse the list and we can get the first 3 elements and we can go ahead. Yeah, that is quite possible and it can work very well, but we are altering with the existing list. What we can do next? We can use stack operations, and till that point, we can iterate all these things, all the nodes, and once we have done iterating, we can pop it out 10, 4, 3, only 3 elements because it's given 3. Yeah, we can also do that as well. There are multiple approaches, but within this approach, we are using an extra space, but we don't want it to have that extra space. How can we optimally do that within within this, also without altering the list? You see, one such example, or sorry, one such solution also can be like, let's go ahead and let's count the number of elements first. So within this, I say that the number of elements are 6, and 6 minus 3 is 3. So let's start counting from 3. 0, 1, 2, and this is 3. So from 3 onwards to the rest. Yeah, we can do this, but mind that we are requiring 2 iterations. So one iteration to get the count or the number of the nodes within the list, and next to get the actual sum. Yeah, this is by far the most optimal solution, but can we do more than this? The answer comes out yes, we can do more. Rather than having 2 nodes, one for finding length and one for finding the sum, we can have two iterators, such as like I'll have a node, let me make some space, I'll say node first and second. Initially, let's point first to head, and we'll say that hey, I wanted this first to iterate till the end, so that when the time comes that I am uh, just about to hit the end of the linked list, my second node or second pointer should be in the optimal position where I'm pointing towards 3. How can this be possible? This is very well possible if the difference or the distance between first and second is just n, no less, no more. So for this, we need to calculate hey, that int I is equal to 0, it's nothing but I is equal to 0 as less than ni plus plus. So here I'm incrementing first, so that I'll give a first a head start. So first is equal to first dot next. It might happen that first would also go ahead and make b null, so I'll just take precaution of that as well. First is not equal to null, I'll say, and yeah, I'll go forward. It might be possible that hey, first can be null and we have not yet reached I till n point. So if I is still less than n, then I'll say hey, throw new illegal argument exception. This will happen in this case like if I'm having a linked list of 1, 2 and 3 and I'm providing n is equal to 4. This can never be a solution because the linked list size is itself 3 and we are providing n4. Obviously there might not be any test cases, but hey, it's good to have within an interview such kind of validations and test cases covered. Now, considering that we are having first at its optimal position, let's initiate second. So second would be head. Now we are sure that second and first are at optimal position. So now this is clear. Let's go ahead and iterate till the point we hit first as null. So first, till the point first is not equal to null, I'll go ahead and say hey first, advance yourself, and also hey second, advance yourself as well. But till the moment first hits null, it means when the loop ends, it means that first hits null, or in other words, the list ends here with first, or I can just say that from second including it we have only n nodes, and that's what we want. So I'll say int sum which is initially 0. While I'm saying that second is not equal to null, just go ahead and add sum from second.data and advance second.next, and at the end of this loop we'll be having the sum recorded like this, and we'll be getting our optimal answer. Easy peasy. So let's compile this for and test compiler errors. So there seems none. Let's submit this. So the time complexity and space complexity, it's quite obvious. Time complexity takes off n, and space it doesn't take any, so it's constant. And also it seems that our solution has been submitted and accepted, and that was all about it. If you wanted to see more such videos related to linked list, click the video on your right, and I'll see you in the next one.